Hello, good morning, friends. There are 23 students who have joined. So today is our 31st lecture. I am wishing to start unit number 4. So before going ahead, just I want to request you to tell me whether you are able to see the PPT as well as a video in a corner comfortably. So please raise your hand so that I will start the session. Thank you, Tanmay, Homeshwari, Chetakshi, Aman, Abhishek, Rasika, Om, Mandar, Swaraj, Gauri, Prasad, Sanskar, Kaustubh. Shivani, Sampada. So, okay, friends, thank you for showing that you are able to see the PPTs as well as my video in corner. So I will begin. Thank you. So let me tell you that this unit number 4, 5, and 6, these are all theoretical units. You don't have to do some computation. There are definitely some algorithms are there, but these are not that much complex algorithm like building some parsing table or something like. These are very straight. If you read it, you will understand it. And typically, the 4th unit, which is a theoretical concept, we shall see what is the limitation, advantages, why we should learn about the SDT, that is a syntax directed translation. Actually, I will talk about it, but let us go through the contents. So this is the agenda. So today I will just roughly, broadly will tell you what is a SDT, means syntax directed translation, and SDD means syntax directed definition. D is for definition, T is for translation. So I'm not going to give you any standard definition in today's session. Tomorrow I will be giving you the exact definition for the SDT and SDD. But today I will tell you what is that and why it is needed. Then we are going to understand what is the meaning of the syntax semantic rules and how they are used, why they are important in generating the code. Like basically what we do in compiler, we generate intermediate code and then we generate the target code. But first we generate intermediate code, then we try to optimize the intermediate code, and then we generate the target code. Normally, it is not a good practice to directly generate the target code. But SDT or SDD allows you to convert directly a source code into target code. This is the beauty of this technique. Actually, this is a technique or a technology. So as we have seen in compiler, there are different types of pages are there. As I told you, no matter we are learning about the 6 or 7 pages, because for graduate level, we learn only that. But if you go for a higher level, means if you go for a post-graduation, there is some subject like advanced compilation technique. So in that, you will find that there are more than 7 or 10 or 12 pages in a compiler actually. And for example, intermediate code generation is there. So there might be high level intermediate code generation, medium level intermediate code generation, low level intermediate code generation. Means in this way, for IR only, means IR means intermediate representation. For IR only, there can be only 3 different phases or passes in a typical compilers. So that is not in our syllabus. Anyway, so what the point is that it is not good to directly generate a target code. We should generate the intermediate code and then we should convert that intermediate code into target code. This is actually a standard practice. It is followed by production compilers. Production compilers means what? Whatever you are purchasing or getting maybe from open source or commercial source compilers. For example, I don't know, but I suggest you to visit the site gnu.org. Uh, so I will be giving you that URL later. So you visit there, you will get large number of compilers, means Fortran compiler, C compiler, C++ compiler, G++ compiler, or GCC, BCC, like different variations are there, means Pascal, Java, and so many compilers are there, and different versions are there. And, and also the compilers are means machine specific, means 32-bit compiler, 64-bit compiler, means RISC-based compiler, like Howard Newman or Howard architecture is there, Van Neumann architecture is there. So it depends on the architecture. You have to choose particular compiler. You have to download that compiler. No matter your language like C or Java will run, or for a programmer as an end user, he will not see anything on bottom of the hood. But compiler is actually designed with respect to architecture, in terms of bits, in terms of typical architectures. For example, CISC is there, RISC is there. There can be hybrid architecture can be there, or there is a power series architecture. There might be Spark architecture like that. So today we are going to see what is the meaning of the conceptual view of SDT. What happens? Conceptual means view means what? We are going to understand what happens in SDT, syntax directed translation. Then I will try to give, not today, but we shall try to understand what is the annotated parse tree, or AST means annotated syntax tree. And there are some concepts of attributes like synthesize attribute, L attribute, S attribute, inherited attributes. So different types of attributes are there. We shall see that why it is important and where it is used, that we are going to see. So today I am just roughly giving you general idea. Now this is the syllabus. So please visit the FTP site. So that IP is given there, 103, 107, 17 and 41. You can go to the public directory, and in that there are many directories are there. You go to the third year 3R CSS, you will get material. You will get the complete syllabus and some programs, ready-made programs. You can download them at your end, and you can run those programs. You can modify those programs. Anyway, this is a fourth unit. We are typically, this is theoretical, conceptual. So we are going to understand in terms of definition, not today, but tomorrow, what is exactly SDT, then what is a SDT, that is syntax directed definition. Then there are, as I told you, there are different types of attributes. We are trying to understand the definitions and importance of different attributes. Then as we are familiar with the syntax tree or parse tree, but there is one more concept. This is a dependency graph. We call it as a DAG, normally directed acyclic graph. We shall see what is the importance of that. Actually, DAG is nothing but it is a graph which has some arrow, and we traverse the tree structure or graph structure. So that arrow helps us how to traverse a tree. For example, when you consider a tree like a binary tree, then there are different ways to traverse. You may do pre-order traversing, you may do in-order traversing, and you may do post-order traversing. So every method has some advantage as well as maybe some limitations can be there. Anyway, now here we are going to understand, see, while learning the bottom-up parsing and top-down parsing, we learn how the syntax tree is constructed. So here also, we are trying to understand how syntax tree is generated when we are doing the translation. Actually, SDT means what? You are directly translating that code, is given code, a string of code or statement or set of statements directly into target-like code or machine-like code. So when we do the translation, that time syntax tree is generated. For example, in bottom-up parsing, we suppose that it is generating a parse tree means bottom-up parsing or LR parsing with rightmost derivation in reverse order. That is a concept. We have seen the visualization. We have seen the through the diagrams. So here also we shall see how the syntax tree is generated. Then there are ways. For example, if you are doing top-down parsing, then you generate a tree from top, like root is there, then parent, sorry, children are there, then kids are there, again kids are there, means until the lowest level, that is a leaf level is there. So we can generate a tree from top to bottom or bottom to top. So bottom up parsing and top down parsing. So here we are taking one example of both, how to construct a syntax tree by using the LL parsing method and by using sheep reduced parsing method, that is bottom up parsing. And then we shall try to understand how to design a predictive translator. See, here we are not talking about the predictive parser. Here we are directly thinking in terms of translator. Predictive translator is something like enhancement of top-down parsing mechanism along with the ability to translate source code into some kind of target code. So that is there. So roughly the content of syllabus are very small. Actually, if we go in 4 or 5 lectures, we can finish along with the sufficient number of examples. Again, you have to refer the chapter number 5. I have shown here in right corner the icons or books. So I have already uploaded those books on FTP site, or even you can download it from Microsoft Teams site, class material, or like. So chapter number 5 is there. So you don't need to read a complete chapter. You have to read only point wise, means just read that topic which is related with the SDT, SDD, dependency graph, then definitions of attributes, and then bottom-up parsing and top-down parsing, and some like or predictive parsing. Means only read that, and I skip the detailed sections in that chapter. There is no need. That's why I said that the syllabus typically for this unit is very small. So both books are there. So last wala, that blue color book is a recent book. It is available on FTP. Now let us go with because it is not wise to directly explain what is exactly SDT and SDD. Let us go step by step. So this slide tells you it. This slide tries to simplify the things. For example, SDT, syntax directed translation. So actually SDT means what? It is a way of translation. Means how you are doing it. That is what SDT is there. Means it is a way of translation. As I told you that there are different ways. For example, in the parsing, there is a top-down parsing way is there and bottom-up parsing way is there. So in same way, you have to visualize what is SDT. So way of translation. It is related to the translation, how to do it. And what is SDD? Syntax directed definition. So actually, so we know that there is something called as a grammar is there. Given grammar is already given to you. Then grammar has production rules. You know what is production rule? Production rule contains LHS and RHS. LHS is normally some capital letter, non-terminal is there. And on the right hand side, there can be string of terminals or non-terminals or combination of terminals and non-terminals. So that is there. But in SDD, we have something more that is called as semantic rule. We shall see what is that semantic rule. So production rules are attached with semantic rules. So I will be giving you the exact definition of what is semantic rule, just like a production rule. But today I am going to give you the example, so you will understand even without definition that what is the meaning of the semantic rule. You already know what is a production rule. So semantic rule is nothing but it is a minor modification of production rule. So certain attributes or certain information is added into the original production rule, and it gives the meaning of that particular production rule. So SDD is used to evaluate the meaning of the statement, semantics of a statement. See, here what is happening in this subject, that in beginning we learn about the lexical analysis. In second step, we learn about the syntax analysis. And in third, we are not learning about the semantic analysis. What we are doing, we are directly learning syntax directed translation. So definitely there might be some gap, but we shall try to bridge it. So SDD is used to evaluate the meaning of the statement, that is semantics of a statement. So statement can be a programming language statement. It can be a single statement. It can be a block of statements, like if then else, or some block can be there. For example, for loop can be there, and some condition can be there, and then in that loop there can be 3 or 4 statements. So you execute them that much times. So this is a very brief introduction to SDT and SDT. So SDT means how to do the translation, and SDD means how to get the meaning of the statements, programming language constructs. Now here there are certain terms. You just go through it. I will be telling about it. We are trying to get standard definitions of it, because nowadays definitions are very important. You should have a standard definition from standard book or standard material. So it is good practice to have a commonly or frequently asked definitions in your notebook somewhere. So for example, SDT and SDD, I will be giving you the definition. This is a major concept. We have seen that. Then there are different types of translation schemes are there. So right now, basically there are 3 methods are there. Means how to do the translation. So that we shall see. Then we are going to understand how to construct the parse tree during translation. How to construct the parse tree during translation. See, whatever we have seen up till now in a syntax analysis, we have seen how to construct the parse tree or syntax tree during parsing or syntax analysis. But here, little theoretically, it is little different. Here, we are trying to understand how to construct a syntax tree during translation, directly translation from source code to target code, or maybe machine-like code. So we don't know exactly our target code is exactly in terms of zeros or 1 or whatever. Then there are some methods are there. All are not important, but you should have a standard definition. You should know what is the importance of the post-order traversal. And you might have learned in data structures or maybe in discrete mathematics, depth first search and breadth first search. So I suggest you get the applications of all types of traversing methods, typically tree traversing methods or graph traversing methods. So you can Google it, or you will get the definitions from your data structure or discrete mathematics, and get limitations as well as advantages and limitations or disadvantages of each method. So typically in compiler, we generally prefer post order. So there must be some reason for it. So try to identify that why post order traversing method is important than in order or pre-order. What could be the problem with the pre-order or in order, or what problems a compiler can face if we don't use the post order method. Like, so you have to think in terms of application, means where exactly it is used. Broadly, almost all methods can be used in any compilation technique. Now, I will be giving you the conceptual view. It is simple, just concept. It's simply a concept. Don't worry about it. Then we shall learn about the dependency graph. Once we have a syntax tree, then we can create a dependency graph from that syntax tree. Many times what happens is that you can represent your expression. Say, expression grammar is there. We have seen that E is equal to E plus E slash E star E slash uh, something ID in bracket E, like that. That grammar is there. So if you have some statement, then we can generate the parse tree or syntax tree. And from that parse tree, by using typical way of traversing, we can generate a dependency graph. Now, the importance of dependency graph is that if we are able to minimize that dependency graph, actually dependency graph is generated from the parse tree. So if we are able to minimize that graph, if we are able to minimize number of nodes or maybe number of edges from that graph, it means that whatever intermediate code we will generate in next phase, that will be optimized. If your graph contains dependency graph contains large number of nodes and edges, it means that the ultimate generated intermediate code will be in large size. But if you reduce it, you will be able to minimize your intermediate code. That is that we are going to see here. Now there will be definitions. We shall see what is synthesized, what is inherited. As you are already familiar with object-oriented programming concepts, maybe while learning Java and all that. So similar kind of things are used here, but we shall see there are actually 3 or 4 types of attributes are there. Attribute is nothing but it is a field. For example, if there is a database table and there is a information stored in it, like roll number of name of the student, year of a student, branch of the student, subjects, passing marks, and all that. So whatever fields are there, every field has some name. So that is called as an attribute. Same thing is here. So what we are doing, that these attributes are attached to tree. So every tree has something called as a node is there, or leaf is there, or root is there. So certain kind of labeling is there, means naming is there. So there can be synthesized attribute, there can be inherited attribute, there can be L attribute, there can be S attribute. I will be giving you, there is a difference in all that. Means S attributed tree is different, L attributed tree is different, but later we shall see exactly definition along with the example. Then there is a concept of side effect that we shall see. Then AST concept is there, that is an annotated parse tree that I am going to show you immediately. Then there is an algorithm that how to traverse. Actually, it is not needed, but we shall try to see what is algorithm to generate the dependency graph. Then semantic rules are there. Some means how to derive a meaning from a statement, whatever statement, a programming language or construct is there. So there are 3 methods are there. One is called as a tree-based method or a parse tree-based method. Second is called as a rule-based method, and third is called as a oblivious method. So we are focusing only on tree, means parse tree-based method. So point number 11 is that how to get the meaning of a statement or programming construct. So there are 3 ways. One is a parse tree based, second is a rule based method, and third is a oblivious method. So every method has some advantages as well as limitations. Then there is a definition for L attributes. So we shall see what is L attribute. So L attribute is something, you know, that every production. One minute. Hello. हाँ हाँ. हो लेक्चर चालू आहे सांगा ना. बरोबर. So sorry friends, L attributes means what? See, in a production rule, there is a left hand side is there and right hand side is there. So L attributes means something related with the or value related with the left hand side of the rule. There is nothing like a R attribute, right hand side like thing. Anyway, and then we shall see at the end what is a intermediate. Actually, it is not. It should not be immediate code. Actually, it should be intermediate code generation using SDT. So we shall see some examples like you can use 3 address code, 2 address code, 0 address code. So perhaps you have learned ALP, assembly language programming, or maybe architecture. In that you may have learned about the types of instructions. So in that 1 address instruction, 2 address instruction, 3 address instruction, like that you might have learned. So just brush it somewhere, read it, that what is that. Basically, it is not directly in the syllabus, but there are some terms like quadruples, triplets that we are going to see. I will be giving you 1-2 examples. So in short, this slide tells you simplified outlook at the SDT. So SDT is nothing but it is a specification of translation, just like a specification of car. When you say your car, then you say it is a 4-wheel drive, it is a power window is there and all that. Same thing is here. So when there is a programming language construct like some statement or some set of statements, then how to derive meaning from that statements, programming language constructs. So specifications of translations are there. So that is called as SDT. And whatever production rules are there, they are associated with the semantic rules, equivalent semantic rules. I will be showing you immediately after this slide. So means how to do the translation, how to use the semantic rules to do the translation, that is there. So anyway, this will deviate you, but in general, compiler has 6 pages or 7 pages or whatever. So we have seen only lexical analyzer, syntax analyzer only, or syntax analysis only. We know that in a first phase lexical analysis, we generate string of tokens, and those string of tokens is passed to the syntax analyzer. And syntax analyzer generates something called as a parse tree or syntax tree. And that syntax tree is passed to next phase. That is you can call it as a semantic analyzer. So semantic analyzer take parse tree or syntax tree as an input, and it generates AST as a output. AST is a annotated syntax tree. So we call it as a decorated tree. Means see, AST contains tree along with some information, some values, some attributes, and attributed AST means what? Detailed values of information about all the nodes and leaves and all that. So try to understand, try to recall what is the definition of the interpreter, what is the definition of the compiler, what is the difference in that. You know all these things, but still to understand the concept of SDT in comfortable way, you should revise those definitions. Now, compiler, when we do the translation, every time we need some information. And what information? What we do generally, you recall previous diagrams. there was something called as a symbol table. Symbol table is something data structure where information about uh, symbol table is a simple table type or database like structure which contains information about the everything in that program. For example, a program can have variables can be there, different types of structures can be there, records can be there, then arrays can be there in your program, main program source code, and the variables can be of some type. You can call it as a data type, whether boolean, integer, a float, real, or whatever. Or there can be structure. When there is a structure like student, then student structure may have roll number, name, city, address, like. So structure fields can be there. So whatever information is there, or a program may have some function or procedure. A procedure may have some parameters, 1, 2, 3, 4, or you can call them as arguments. So, there is a way of passing the parameters, call by value, call by reference, call by text, or whatever. So whatever the information is there about the variables, functions, procedures, records, structures, length, size, then dimension. For example, if there is an array, then there can be dimension information like one dimensional, two dimensional, or three dimensional. So that information is stored in a table that is called as a symbol table. So if you recall the first unit PPTs, so there I have given you that what information is kept exactly into the symbol table and why it is needed there. Again, there is one term that is called as a scope that we shall see later while learning fifth unit. So every variable has some scope that we shall see later. So that scope information is also there in that symbol table. So that information is nothing but, or values is nothing but, we call them as attributes. As I told you that attributes can be L attribute, S attribute, inherited attribute, like. So these attributes store relevant information of that particular construct or sentence. So in this way, intermediate code is passed to the code optimizer. Code optimizers, there are standard methods to optimize the code. So it reduces the number of lines in that intermediate code, and then we generate the actual code. So like this, this is a compiler structure roughly. Now, let us see why attributes are needed. So here this slide tells you, there might be some repetition, but you just go through it. It will definitely help you. For example, there can be some expression. So there are types of values, like expression can be a plus b plus c, like, or z is equal to a plus b. So operators are there, like equal to operator is there, plus is there, and whatever. So type value is there. So type value can be integer, float, double, character, string, or whatever. Then type of constructs can be there. Type of constructs means, you can just try to understand it. What is that? So it can be some variable, it can be some constant, or it can be some operation like addition, subtraction, multiplication, or division. So, or you can define it. For example, in C, you do something hash define or def, and you define something, that macro type thing. So a type of constructs can be there. A type of constructs comes under variable, constants, and operations. Now, when we talk about the constants, then there is a value. It can be integer or it can be real or whatever, but value is there. That is attribute. Means type of value means is different thing. Type of value means whether it is an integer, float, or double or something. And actual value is something. Suppose I declare x as an integer. So X has a type value of integer, and its actual value is, say, X is equal to 10, suppose. 10 is its actual value. That thing is there. In same way, attribute of variable. So attribute of variable can be name. Means name of that variable can be X, like, or scope can be there. We shall talk about what is scope later. Now, there can be operations. So it may be Boolean operation, it may be arithmetic operation, it may be some operation like parity, or it can be some operator like. So attributes, so operation also has some attributes. So right now we are not understanding what is the meaning of the yes attribute, what is the meaning of the synthesized attribute, what is the meaning of the inherited attribute, what is the meaning of the like yes attribute or L attribute. We are not, right now we are learning. What we are learning, we are simply understanding what is attribute. So attribute is nothing but it is some kind of value or type. It can be a value or type. So perhaps this slide may have explained enough. Now, this is the diagram you should have in your copy. You can take the screenshot of this. Normally they ask you what is the conceptual view of SDT. Is what happens in syntax directed translation. So these boxes tells you what happens in syntax directed translation. See here what is happening. There is an input string, or there can be programming language construct. So that is converted into parse tree or syntax tree. Then from parse tree you generate a dependency graph. From dependency graph you evaluate the order of semantic rules. Yes, how to derive the semantics or meaning from that construct. That's why it is called as the evaluation order. कैसे करेंगे evaluation order? So there must be some sequence. So what is that sequence? It comes when you traverse a tree in particular way, say in order, pre-order or post-order way, you traverse a tree like this. From root, then you visit nodes or leaves, then you come up like this, and then like. So in this way, you visit all the nodes in that particular tree. So we shall see that. So this is the actual, in brief, conceptual idea view of SDT. So we have a programming language construct. We construct the parsing tree from it. If we have a parsing tree, we construct the dependency graph from it. If we have the dependency graph, then we estimate evaluation order of the semantic rules. Now, these are the two lines are there. These are very important. So just why semantic rules are needed? So two things are there. So attribute, as we know, it can be type or it can be value. So attributes are associated with the non-terminals. Please note this thing, or you can write in your copy. Attributes are associated with non-terminals, and semantic rules are associated with production rules. Production rules are related with the grammar, given grammar. So I hope you got this screenshot of this. You can send it to me. Now this is a bit theoretical. I will just read it. Whatever is there in this slide. Actually, most of the part in this unit is theoretical. So syntax directed translation is used to define the translation of a sequence of tokens in some other value to some other value based on context-free grammar for that input. Syntax directed translation is defined by associating a translation rule. Translation rule means a semantic rule with each grammar rule. Means there is a production rule, there are a number of production rules. In same way, there is a corresponding semantic rule. For every production rule, there is a corresponding semantic rule. The translation rule defines the translation of the LHS non-terminal as a function of RHS. Just read it. The translation rule defines the translation of LHS non-terminal as a function of RHS non-terminal. So see, in the right hand side there can be non-terminals or there can be combination of terminals and non-terminals. That is not a problem. So every non-terminal has some attribute, right? Even a terminal or operator can also have some attributes. So we have to evaluate the values of those attributes. So the values of the RHS terminals. So anyway, later you read it. Now there are some two blue lines are there. Just I will read it. There is no restriction on type of translation. As I told you, there are three ways to do the translation. One is called as a parse tree based translation. Second is called as a rule based translation. And third is called as the oblivious translation. Anyway, there is no restriction on type of translation. It can be simple type like integer or complex type like abstract syntax tree. Means tree itself can be a structure, just like a record or some variable like X. Typically, SDTs are implemented during parsing without building a parse tree. See, this might be confusing, but let us try to interpret it. See, I have given you in TEC the assignment of static code analyzer. See, in compilation, what happens? We have a source code. Compiler processes it in various phases and generates a target code. But there are static code analyzers like Gajanan is there, or you can visit that slide. I will be showing you at the end. There are many tools. So before compiling, you can test the validity of your code, whatever you write a code, and that static analyzer, code analyzer will give you hints in terms of some colors like red, green, blue, and you can correct your code for effective programming or successful coding or correct coding. Many times what happens when you write some code for some task, then you don't know whether it will work or not. What you have to do, you have to compile it. There might be some syntax error or something. And sometimes it may happen that even though there are no problems, your code runs, you give something as an input to that your code and you will get something as output. But sometimes on some input, your code will not work properly. Then you don't know whether it is working, means whatever your algorithm, whatever you implemented is working correctly or not. There is no way to guess that thing. So that can be something called of a kind of a logical error, but this logical error is not a sufficient term to capture that thing. What I mean to say is that if you write some code, it works successfully on most of the inputs, whatever inputs you give them. But sometimes you don't know, on some inputs, your code don't give you correct output. So that can be there. So same type of concept is here. SDTs are implemented during parsing without building a parse tree. मतलब parse tree build करने का process mechanism अलग है. We have seen it in a top-down parsing and bottom-up parsing. We know how to realize the RMD in reverse and how LMD in a order, and how to visualize the syntax tree. Actually, syntax tree is never generated. It is simply the application of production rules, the sequence of production rules, how you apply. And in that way, in abstract way, you assume that there is a successful construction of a parse tree like that. Anyway, we shall talk about it later. Now let us take this example. Suppose this is a expression. It can be some construct like if then else, do while, repeat until, or something. Let us say this is a programming construct, programming language construct, 2 plus 3 star 5. Now what happens? If you translate it, means what? You want to find the meaning of this statement. It is given in red color. So you can do something like this. You can do 2 plus 3 is equal to 5. And 5 into 5 will be 25. So that is a meaning. 25 is a answer of this expression. So meaning of that expression. So 25, you have to think whether 25 is correct meaning or not. But you know that multiplication has a higher precedence. So what you do? You multiply first 3 into 5, that is 15, plus 2, that is 17. Means 17 is a meaning of, means what I want to say is that if you do in wrong way, you will get wrong meaning. Like, or you will evaluate the meaning in wrong way. So the whatever translation methods are there, SDT methods are there. So you have to take care that you have to design in such a way that you will get a correct meaning or correct valuation of that particular expression or maybe some programming language construct. So specification rules are used to do such translations. Translation can involve adding information into the symbol table as well as performing specific computations. Now, just recall the previous structure of the compilers. In that there are some pages are there. There is on one side, there is a symbol table. On another side, there is a error reporting mechanism. And all these pages are linked with the symbol table as well as error reporting mechanism or error reporting routines. So what I want to say is that when you do lexical analysis, when you do syntax analysis, when you do semantic analysis, when you do intermediate code generation, when you do intermediate code optimization, and when you do target code generation, in all phases, in all the processes, you have to interact with the symbol table. Sometimes you have to add some information into the symbol table. Sometimes you may have to modify some information from the symbol table. It depends on the typical phase where you are at that moment. And sometimes you may have to delete some information from the symbol table. That could happen. Means addition of information, modification of information, or maybe deletion of some information from symbol table can occur. So that is what it is explained in that line. Translation can involve adding information into symbol table as well as performing some specific computation, some operation, maybe modification, deletion, or creation. Now let us see this. So you have to visualize this programming language constructs in terms of syntax tree. You can call this as a syntax tree. So as I told you that you can do, if you do it in wrong way, you will get answer or meaning as a 25. But if you do it systematically, then you will get the correct answer. Means 3 into 5 is equal to 15. This is the value of that particular root node. Means that is a parent node, and root is a plus. And 2 plus 15 is equal to 17. So in this way, 17 is a meaning, semantic meaning or a semantic value of that given statement. So no matter, this is expression statement, but there can be if then else, repeat until, or some case statement or switch statement in like C language. So we have to evaluate it. So whatever this tree is there, so here nodes are there. See, plus is there, star is there. These are the nodes. 3 is there, 2 is there, and 5 is there. These are the leaf nodes. So these nodes have some attributes, whether integer, type, length, location. So some attributes are attached to this tree. For example, where this tree is stored in memory location. So it might be stored in some memory location. So it may be octal representation or maybe hex representation in a primary memory. So, so that information related with the location or storage, that is called as attribute. Right now, we don't know what is whether it is a S attribute or L attribute or I attribute. Means I means inherited attribute. So I will go through it. Now, here is a little broad view of understanding what is a SDT. So grammar symbols are associated with the attributes. Grammar symbols, you know what is that? Terminals, non-terminals, LHS, RHS. Attributes are used to associate the information with programming language constructs. So attributes can have some values. Second point is there. Values of attributes are evaluated by use of semantic rules. See, the values of attributes are evaluated by use of the semantic rules. I will be just showing you after this slide what is a semantic rule. Now, you have to understand semantic rules are associated with production rules. As I told you that there can be grammar, there can be set of production rules, and for every production rule, there is a corresponding semantic rule associated with some semantic rule. Now, whatever semantic rule is there, that semantic rule can be with some attributes. So semantic rule with inherited attribute, this is the one. Second is that a semantic rule with synthesized attribute, means that is there. So semantic rule is associated with some attributes, maybe synthesized attribute or maybe inherited attribute. We shall see what is exactly synthesized attribute and inherited attribute. Now, third point is there. Evaluation of the semantic rules are used for may generate the intermediate code. Means you can use semantic rules to generate intermediate code, or you may use that rule, semantic rule, typical rule, and you can update some information into symbol table, existing symbol table. So that can be there. That's why there is a may is used there. It is not always. Means evaluation of the semantic rules are used for five purposes. Third is there, you may perform some type checking. For example, there is a statement like x is equal to y plus z. Now suppose x is a boolean, y is integer, and z is integer. Then it will be chaos. So you can use that rule to check whether the grammatically and semantically given statement is correct or not. So that is type checking, that is called as a type checking. Actually, type checking is nothing but it is a semantics. Type checking itself is a semantic analysis. Or if there is something wrong, you may issue some error message, and you may perform some other activities. I will talk about what are those other activities later. Now, fourth point is there. Attributes hold anything like string, number, memory, location, complex record, like. So attribute holds some value. It may be, attribute may be integer, then value may be 10, like that. So, and type may be some string or number or some memory location or complex record, or it may be tree like structure, or it may be array. If it is array, then one dimensional, two dimensional, multi-dimensional, n-dimensional, whatever. So that thing can be there, is associated with that particular attribute. And fifth point, evaluation of semantic rules defines the values of attributes. So we shall see through some example that what is the meaning of this. Semantic rules may have some side effects. For example, printing a number, something. I will talk about it. What is the meaning of the side effect? So many times you may have done debugging of your code. For example, there might be some block of statements in your code. So sometimes you want to check value of some variable, say y, during execution of that particular loop or block of statements, and you print it. So actually it is not needed. You need to print something at the end of the code. But to check intermediate, you do some printf statement during the debugging of your code. So that could be called as a side effect. We shall see what is that. Now, let us say, this is the example of the SDT, syntax directed translation. So this whole thing is called as a scheme. This whole thing is called as a scheme. See, in this table, actually, this is not a table. There are three things are there. One is production rule is there. Means given grammar is there, set of production rules are there. For example, here 1, 2, 3, 4, 5, 6, and 7. 7 production rules are there, right? Then their corresponding semantic rules are there. For example, L. L means some statement or line or statement in a code. L is generating E, and there is a return. Return means that enter symbol in your or /n in your keyboard, or /n in your maybe code. Next line. So L is a line generating expression, and it is written. So equivalent semantic rule means what? You have to print value of E. So actually it should be E dot val. Then there is a rule. E is giving you E plus T. Now see here, I have written here E dash. It is just like identifying. See, in one statement there can be multiple IDs. Suppose ID 1 plus ID 2 star ID 3. These 3 identifiers are there. All 3 identifiers are different. We don't know whether they are X, Y, Z and what are their values. But to identify identifier, we put something dash or 1, 2, 3, 4 like this. So you can here write 1 also. Means E is giving you E1 plus T. Because on left side there is 1 E, on right side there is 1 E. So in order to distinguish it, you are putting 1 or dash to differentiate them. तो लेफ्ट हैंड साइड का जो ई है उसका वैल्यू अलग रहेगा, और राइट हैंड साइड का जो ई है उसका वैल्यू अलग रहेगा. To distinguish it, that's why we are putting 1 or dash. And that's why the semantics rule is its equivalent representation. So E val is equal to E dash val plus T val. Means E का value plus T का value जो भी है is equal to net E val, that is LHS. Then E is giving you T. E dot val is equal to T dot val, like that. Again here there are 2 T's. One is simple T and another is a T dash. You can put there 1 also. That is not a problem. So T dot val is equal to T dash val into star F dot val. So in this way, for example, last is there, F is digit. So just recall, we have seen their ID in a previous grammar, expression grammar. Here it is a digit. So digit can be single digit or multiple digit. We don't know. So F is giving you digit. So F dot val is equal to digit dot val. So actually digit dot val is some lexeme. See, recall here what is lexeme. So you know the definition of pattern, token, and lexeme. So this lexeme is operated during the lexical analysis phase. Now programming constructs are there in last column. That is a programming language constructs. So actually it is of no use. It is actually for internal use. It is an internal representation of whatever is there in a semantic rule. So right now, don't try to interpret it. We shall see it, what is its meaning, but you can easily understand what it means. Actually, it is an alternate representation. It is an alternate equivalent representation of semantic rules. So for example, if you see the semantic rule column and program construct column, then print in bracket e dot val is there. So its equivalent representation is print in bracket val, then this is the index in square bracket top minus I. So I can be anything. It can be 1, 2, 3, 4 or whatever. And top is an index. You know, in array there is something called as the index. So that thing is there. So as if you are referring particular memory location or array position. So that is that top minus I, top minus 2, top minus 1 like. So that is there. So val is a name of the array and top minus I, top minus 2 is a index of that array. So this is the equivalent representation. So anyway, so whole this table is giving you a complete SDT and SDD also. Means SDD and SDT means what? See, production rule is there and how to evaluate it. Corresponding semantic rule is given. That's why it is called as SDD, syntax directed definition. How to evaluate it? So you have to refer this semantic rule to evaluate particular production rule or to evaluate particular occurrence of production rule. Anyway, let us go ahead. So grammar symbols, non-terminals are associated with the attribute values. For example, token digit has an attribute value called as a lex val. So lex val is something like a lexeme type thing. So we shall see it during the syntax tree. Now, see, we have seen this 3 into 5 plus 4 similar statement in the previous slide. If you and we want to evaluate it. See, I just want to go back. See here, slide number 13. So there is a programming language construct 3 plus 2 plus 3 into 5. So, and on the right hand side, there is a equivalent parse tree representation or syntax tree representation. And the values 15 and 17 are given there near that particular node. They are representing meaning of that construct. So here also, it is a detailed tree. Previous tree was simply a basic tree, basic syntax tree or basic parse tree. It was not containing information. Now this tree contains, actually this is a parse tree with more detailed value informations. That's why this is called as an annotated parse tree. That's why it is called as a decorated parse tree. So you can correlate it. Now see, if you parse this statement, what is statement? Statement is 3 star 5 plus 4 slash, sorry, n. If you use this grammar to derive it, you may use LMD, leftmost derivation, or RMD, rightmost derivation to derive this. If you have a derivation, you can construct a tree given here on the right hand side. Now just today, just go through this diagram, try to understand it, how it is decorated. So I'm going to close it. You just download this slide and we shall see the remaining part in next session. So I hope everybody understood what I want to say. I will repeat some part in next lecture. Thank you very much. If you have any doubt, you can send it on my personal WhatsApp. Thank you very much. I'm going to end this session. So Mandar is there. He's listening me. Thank you.